Okay, let me hide this window so have more space. And this is code that was emailed to me. It's not working. So I'm gonna take a look at it first. As you're working with programs, if your code's not working, you're welcome to email to me and first part of class, and I'll either show you what the problem is or give you hints on where to look. I don't think you can use an and symbol like that. I think that's probably the problem right there. Of course, this has to be named the same as the new class. They named theirs menu.java, I'm assuming. Okay. Cannot find symbol. Okay, so if I get rid of that and symbol, not for us. Keep waiting for it to pop up down here. Okay, got another issue. Could not find or load class main class menu. Um, hmm, I don't refer to menu anywhere. Obviously, I do because it thinks it's there. Oh, that's the search for that. Well, let me create because I think it was called menu originally. See if that's a true statement. It was called menu originally. Okay, so do a new project. Java application, test. Right click on source package, do a new Java class, call it menu, finish. Get rid of that and try to run it. Select the main class. Looks like it needs some slash F's there, but let me put that there so I can actually see it a little bit better. Um, 5 to exit the program. So down here, if I put 5 in, press enter. Okay, exits out. Okay, that's the right slash. Okay, so now I run that. That's weird. Wrong slash, I guess. That ain't got a memory. I could probably do things twice as fast. Okay, come down here, do 5. Okay, right. Okay, so it comes up. I'm going to put 4 for 4 since I know that formula. Mass 33, acceleration 3 should give me 99. Okay, it looks like that was a main issue for this particular program. And sometimes with the debugging, you'll see that first thing I didn't try to understand the code. I look for red squigglies. It'll put a red squiggly under where the error is. Also look for a red squiggly in my last curly brace. Oftentimes people will delete a curly brace and that messes it up. So when I was scanning through, it had a red squiggly under this. Pretty much the only thing you could do wrong at that point is the name of it. Assuming you have public, static, and void, integer, double, something here, valid. The only thing you can do here is use like a reserved word. Like if I name that double, for example, something I could spell, it wouldn't like it because that's a reserved word. If you started with a number, I don't think it'll like that because it starts with a number. If you put some kind of special character in there, like exclamation, it doesn't like that. Okay, let me close that. And close this. Trying to get too many open. That's my broke one. So we come down to here. Okay, last time we talked about working with functions. We talked about working with a menu system, and part of that involved the return, returning a value, or just not returning anything at all. Depends upon how you programmed it. Um, our menu didn't need to return anything, but if you need to return anything, you can use a return statement in your method. For example, these are just returns. If I wanted to write a program to simplify a fraction, for example, got my numerator, denominator, and I guess I could prompt them. Scanner in equals to, I'm not going to remember this, but we'll see. Scanner, no memory. System in. So, dot in or in? Dot in. And import java.util.scanner. This is still running. Okay, it's not running. Okay, so now I'm going to ask him to input the numerator. So system.out.print input numerator. And I'm going to have numerator equals to n.next int system.out.print input denominator. And denominator equals n.next int. Let's say you hate fractions. You'd rather not deal with them at all. So we're going to write a program to reduce a fraction. For example, you have 10 over 20, and you want to reduce that. Well, if you think about how you do it by hand, that helps you in figuring out how to do it on in a program. You think of the largest number divides into both of those. Some of you are so good at it that you can. That's probably a bad example. 12 over 20. You think the largest number divides into both of these. Some of you are so good at it you might be able to immediately see it, but you could start with the smallest number, like 12, and ask, are they both divisible by 12? And they're not. So I go to my next one, 11. And they're not both divisible by 11. Then 10. No. 9. No. 8. No. 7. No. 6. No. 5. No. 4. Well, 12 divided by 4 is 3 with a remainder of 0. And 20 divided by 4 is 5 with a remainder of 0. So they're both divisible by 4. That gives us 3/5. Okay, that's an example we're going to work with. Now, we want to call a blank lines. We want to call a method. So public, static. I'm not going to return anything here to begin with, but I'll probably change that. and I'll call it simplify. Now I'm passing my numerator, so I'll say numer like that, and denominator. Now I'm going to have a for loop here, so I don't have to really declare a lot. And I think I can change the parameter, the value of these, but maybe to be on the safe side, I'll have n and d for numerator and denominator. And n is numerator, d is denominator. Now remember what we did here, doing it by hand, unless I was really good, I think of the smallest number, but I could have started at 20 also. But I started the smallest number, and I asked if they're both divisible by 12. They're not. Then I asked if they're both divisible by 11. They're not. Are they both divisible by 10? They're not. What I'm doing is I'm going in reverse order. So I'm decreasing. So here I'm going to say for int x equals, and here I'm going to start with one of them. It actually does not matter which one you start with. Numerator, denominator, your choice. And I'm going to continue while x is greater than or equal to 2. And here, then I'm going to do an x minus minus. What that's going to do, maybe, oh, right there. What that's going to do is it's going to start the numerator, which in our example would be 12. You could equally put denominator here and work also, work a little harder. So it starts at 12, and this x minus minus decreases it through each iteration. So it goes to 11, 10, 9, 8, and so forth. Now here we want to check to see if the remainder is equal to 0. Now remainder is the old school division, where you take 12 divided by 4 gives you a 3 with a remainder of 0. So it'll return us at 0. Now this is the part I may have to Google and see. It's called a modulus, but it's different in different programming languages to get the remainder. So here I'm going to say if my numerator, no, n, because we assigned it to n. If n, and I'm guessing it's percent, divided by x is equal to 0, and I'll probably have to put parentheses around these, but we'll try this. D, the denominator, divided by x is equal to 0. Now, I'm not really comfortable with that without parentheses, even though there's no red squiggly there, because I don't know the order of operations. Does it do the and first? Does it do the this? Does it do this? I have no clue. So I'm going to put parentheses there just to make sure that I'm covered. Now I know what it's doing. I could go out there, I could research it, but why bother? Putting extra parentheses in there does not make it run any slower. Not significantly slower. But I suppose if you're going to take this times do it a million times, maybe it would be meaningful to go look up the order of operations. Some programming languages will just remove extra sets of parentheses. No matter how many you put in there, it'll remove them when it creates the machine code. I don't know what NetBeans does, or the Java compiler, I should say. So what this is doing is x is decreasing over and over. And when x gets down to 4, it comes down here, it says, okay, it's 12 divided by 4, give me a remainder of 0. And does, what's my other number? 20. Does 20 divided by 4 give me a remainder of 0? And if that's true, then this right here, I want to divide, n is going to equal to n divided by x. And d is going to equal to d divided by x. Now, in theory, if we start the larger and decrease, then I could break out at this point, but I hate using breaks. So I'm gonna let it continue through the cycle since it won't hurt anything. And then I'm gonna need to print my result out. So system.out.printf %d divided by %d simplifies to %d divided by %d slash n. And got numerator, denominator, and our new numerator and denominator, n and d. Okay. So I need to call simplify, and I'll pass the numerator, denominator. And hello? I guess I did call it hello.java. Okay, so again, do something you can test. 12 for the numerator, 20 for the denominator. 12 over 20 simplifies to 3/5. So I've now written a bit of code that will simplify any fraction I ever want. I'll never have to simplify fractions the rest of my life if I got something more complex. $11.20 over 2,040. Then that simplifies to 28 over 51. And again, don't panic if you see red anytime you see math. Don't stress. I'm just demonstrating another example of a function. You can equally have a function that does just a simple percent, multiplies times 10%. Maybe you're trying to figure out a raise type of deal. Questions on that example? Now, this is part I'm not quite sure how to do. What I want to do is I want to return, you can't return two values. You can return one value. And so I'm going to change this to return one value, but I'm going to need to return a string. And so I'm going to build a string out of the new numerator and denominator. Later when we're talking about classes, we could actually have a class, an object that consists of a numerator and denominator, and we could return that object. But for now, come up here. I'm going to return a string. So we got to spell it right. This is uppercase S. And then down here, I'm going to build that string. So I guess I need to declare a string. You don't have to declare all of your variables at the top, but it makes programming nice. I'll call it result. Because then you know where your variables are. You don't have to sit there and search through all of your code trying to figure out where in the world you declared it. And result is equal to, and I'm mixing all the languages up. Okay. Integer to string of numerator plus, that's a concatenation, my fraction, slash plus integer to string of my denominator. And then a return result. Now, having a return here, instead of printing out the result there, then it's going to return it to my main program as a string. And this concatenation, it's not a plus, it's concatenation, should take the number like 3/4. So 3 and concatenate with the slash here and concatenate it with the 4. Convert all of those to string. So then in my main program here, I have to have this set equal to something. So up here, I could have a variable called string answer. I could also embed it directly into the print statement. That's your choice on that. And the answer is equal to simplify. So then, system.out_print %d simplifies to, I think it's S. And for here, for my parameters, numerator, denominator, and then my answer, what I returned. So let's run that again. Put down here, and I'll put something like 12 and 20. And that returns 3/5. So it's still working. Now, part of the problem returning it as a string, and we're going to see strings later on, how we can slice them apart and so forth. But part of it is returning it as a string, then it's not something I can easily work with. I have to either parse it apart or, well, I have to parse it apart. If later on when we're dealing with objects, classes, and I return a fraction class, for example, an instance of it, then that's something I can pass into something else. So I could build an entire library on fractions, adding them, subtracting them, multiplying them, dividing them, and not just giving you the decimal equivalent, but actually working with them in fraction form. Questions on returning a value? Okay. This is actually I love programming mathematical items. So you see it creep into my programming classes, unfortunately. But I try to keep it nothing too complex. Things that you'd think how you do it by hand is exactly how you program it. You just we just look at this. We don't have to think, are they both divisible by 12? Are they both divisible by 11? Are they both divisible by 10, and so forth? We can immediately, some people, immediately go down to 4. Now, this next part, I'm not good at. I don't think I'll ever be good at it. And it's recursion. Recursion, when you're talking about methods, is a challenge. Now, this one I'm going to steal because I actually like this recursion. Recursion is where it calls itself. This is actually an excellent example of that. So I want to have a new method here. And it's curious. I'm not sure why they have braces around here. If you have one line of code, you don't need braces. Now, countdown 5. I may try to do something a little bit more meaningful after we do the countdown of 5. Um, Probably won't get it to work, but we'll see. Okay, input numerator 12, 20. That should give us 3/4. And notice how it goes 5, 4, 3, 2, 1, blast off. You might say, well, I could accomplish that same thing without using recursion. Yeah, most of the times you can. You don't need to use recursion. There's going to be some times where you have to, which I'll mention. I think I talked about it in this class about the Chinese restaurant, the buffet, where you have your plates. If I didn't, then I'll talk about it now. But you have your plates that you push down. And so when they put new plates out, they put new plates out and push them down, and then push them down, and then push them down. In theory, unless you actually ever let that go empty, your last plate will probably be pretty dirty. So if they keep pushing it down, and that last plate has gathered dust for probably about 30 days or something like that. Um, a good restaurant will let it go empty, even though a customer may be unhappy to make sure they all get clean. But that's the concept of a stack. And so when you take one off, then it pops up. You can push one down and it pushes it down. Recursion, when it calls itself, it keeps putting it onto a stack. And then when it returns, it's popping it off the stack. So that's a principle. Okay, so I call this first time countdown 5. That's my code. Okay, so it's going in here, and you can almost think of this as countdown past 1. At this point, n is equal to 5. It's doing this is checking to see if it's equal to 0. It's not. So else, and then it's doing a system.out.println in. So it's printing 5 initially. So 5 is on the screen. And then it's calling countdown again. This time it's calling count down with 4. So it calls itself. So we're back to here and running countdown of 4. Jumps, checks here, says, okay, it's not equal to 0, it's 4. Comes down here, prints out 4. So now on my screen, I see 5 and 4 on the screen. And then this n minus 1 is going to do 4 minus 1. And so it's going to call that countdown 3. And then it'll print 5, 4, 3 on the screen. Follow the same pattern. Count down 2, 4, 3, 2, and count down 1. 5, 4, 3, 2, 1. Then I'll count down 0. At that point, comes down here and checks if n is equal to 0, prints out blast off. So on the screen, though these will be on separate lines, you'll see now 5, 4, 3, 2, 1, blast off. Okay, when it finishes that, it was called from here. So it returns from where it was called from. So it comes here, there's no other lines of code. So then it returns from where that was called from. So it keeps recursively, keep it returning to where it's called from. So it keeps track of all this from the programming standpoint. Recursion should be avoided like the plague, unless you have to use it. Where do you have to use it? Well, if I go to C drive, program files, and I got these. I don't know how many folders I'm going to have. I don't know how many folders are under Microsoft Office. Well, what we do is recursively go through it. So I went into program files, I go into active state, Comoda, I go into library, I go into Mozilla, I go into Chrome, I go into English US, go into locale, go into branding. Finally. Okay, so maybe I process whatever's here. Then I go back one. Now I go into under here, I go into English US, alerts. Okay, then go back one. Go into auto config. Go back one. Finally get down to places. Go back one. And since I've went through all this, then I need to pop back to here. I already went through English US, so I pop back one more. I already went through locale, so I pop back one more. Now I go to icons. And then I continue the same process. Whenever you do a search for a file, that's what it's doing. So if you're writing a system utility, recursion is essential. Now, whenever I've had to use this in the past, recursion hurts my head to program anything too complex. Even the simple ones do. So what I did, so if I wanted to recursively go through all the files on my drive here, not that I can remember how to do it, slash, is there a help? Okay. Recursively go through all the files. There used to be. I'm not sure if there still is. I would have guessed /r, but I'm thinking probably Linux. Okay, displays files with the specified attribute. Uses bare format. No ending. Display the number separator. Same as width. Uses lowercase. List by files. Pauses after each screen for displays the owner of the file. Display alternate data streams. Display files and specify all subdirectories. /s. So I do a dir/s, and then I'd redirect it into a file. I didn't like something about it. Access is denied. got access to TMP. Might not be any folders under it though. A lot of files. Yeah, there's a directory. Good. Just one. A few maybe. So dir/s redirected into David's file.txt, and list notepad. David's file.txt. That'll bring up everything in that under that folder and the subfolders and everything. If I were to browse through here, you can have it display files. You can have it display just directories. So there's lots of different options. When you display just the directories, then that gives me a file I can just loop through and open up each one of those directories and search inside of it. That is not the best in terms of recursion. That's a very simple way to do recursion. So you don't have to, and whenever I've had to do it, I've been under the gun anyway, so I didn't really have time to do recursion correctly. Okay, now I said I was going to try to do something. Might not be successful, but I'll try to calculate. Maybe I can use a countdown as a pattern, but I want to do factorial. Let me get rid of this fraction one. Now, talking about factorial, factorial looks like this. It's a common one to program in a programming class. You can do it very easily with a while and for. Recursion is a little bit more challenging, but what that 5 factorial means, that 5 exclamation, it means you multiply 1 times 2 times 3 times 4 times 5. Okay, so let me change the countdown to say factorial. Initially, my answer is probably a better way than I'm going to do this, but okay. So initially, my answer is going to equal to 1. Now I need to pass in some value here, and I could do that. So I guess if I pass it in there, I don't need to set it equal there. I wasn't lying when I said I'm not great at these. Okay, I don't need to go down to 0. And when I get down to 1, I guess I'm ready to print my answer. So system.out print line, and I'm going to be passing in, or the answer is what I want. I don't want that. I'm going to be calling factorial. Answer. Not sure why the book put those curly braces there for one line of code. You don't need them. If you got 2 or more lines of code, you have to have those curly braces around there. Head's hurting already. Let me think about this. 5, 1. So I'm passing in 5. I'm reducing 5 by 1 each time. So 5, 4, 3, 2, down to 1 where I print my answer at. So I keep bringing in the answer 2, which means I need to update the answer. So here, answer is equal to answer times n. That's not comforting with that little yellow line under there. We'll recurse infinitely. Oh, because now I need my curly braces. Remember I said if you got two or more lines of code. Infinite loop means it'll never stop. There was one I wrote the other day. I forget what, I think that was in, I don't even remember which programming class I was in. I couldn't even stop it via the IDE. I had to kill the package or kill the program by doing Control Alt Delete and going to Task Manager. I outdid myself there. Now 5 factorial should give us 20, 60, 120. So let's see if it works. And it gave us 120. Now I said factorial should be avoided like the plague because while it may seem like, well, that's kind of powerful how it can call itself, and then you just decrease the value or increase the value appropriately. But if you call itself too many times, you'll have an overflow error. Stack overflow, I think, is what it will give you. I don't know if I can achieve it here because my n might become, or my integer might overflow before I even get to that point. If I put 120 here. I'm not sure if I'll exceed the limits of the variable first or 0. Okay, I didn't get an error, so I'm guessing I exceeded the limits of the variable. Of course, 120 is just calling itself 120 times. That's not a whole lot in terms of your stack. Now I did this inefficiently. Let me show you some good code. It's a standard one, so you find tons of examples out there about factorial. I shouldn't have had to put the answer there, but I couldn't wrap my mind around how to do it any other way. I don't think I needed it. Java recursion factorial example. Doing a loop on recursion. Factorial program. See, I knew I didn't need that extra variable. I just couldn't wrap my mind around how to do it. So to find the factorial, like you pass in 5 here, comes down here, sets that equal to my parameter num. And then here I'm returning num times and then multiply the numbers. And it's passing in num minus 1, which would be 4. So what this looks like as you build it up, it's not that way in memory and so forth, but the concept is that way. First time you run it, and let's say num is 5. So it returns 5 times multiply numbers 4, which then does 4 times multiply numbers 3. which then does 3 times multiply numbers 2, then does this times multiply numbers 1 greater than or equal to 1. Okay, so it's passing in 1 for a number. So at the next call, since this is only when it's greater than or equal to 1, this is where we get down to the next one, where num is equal to 0. Then that comes down here and does this return 1. It's like, return 1. What in the world does that do? Well, that returns the number 1. It returns where it's called from. So it comes here, this is where it's called from, and it replaces that with 1. And then, again, there's a return before each one of these. Two times 1 is 2, and then it returns it. Where it returns it to is right here. So it puts 2 there. Then 3 does 3 times 2, which is 6, returns it, and where it returns it to is this right here. And so it puts 6 there. 4 times 6 is 24, returns it, so it comes up here and puts 24 here. And then 5 times 24 is 120. Returns that from where it's called from, and that would be our initial call up here. So that's a concept of recursion. Each time it does one of these, I don't know if I can undo and undo or not. No, I can't. There's only one undo. But each time it calls one of these, it pushes it down on the stack. And the stack has limited resources. So at some point, if you're pushing too many calls down on that stack, it'll overflow it. Probably more than you want to know about recursion. Like I said, in most cases, you don't need to worry about using recursion. It's when you're writing system utilities where you have to do it, unless you do it sloppy like I did. I've never done that kind of coding. That kind of coding is when you're writing system utilities for Linux, for example, where you have to recursively go through every directory. If you're writing a method to like a program to recursively, system utilities is about the only thing I can think of. Some math. Okay. Here's where it's talking about pushing them down on the stack. Binary numbers might be where you could use recursion. Think about it. Because if you're recursively going through the digits in a number, well, you don't know how many digits it's going to be there to begin with. And if those of you who have seen the process before, you have to do old school division, and you divide by the number like 32, 16, 8, 4, and then the remainder becomes your new what do I call it? New key number. And so then you go through a process. You divide it, keep it recursively going through, and it keeps lowering the key number down. So yeah, that'd probably be a good example of using recursion. Let's convert a decimal integer into its binary representation. You repeatedly divide a number by 2. Well, that isn't quite what I was thinking about. That's not how I showed it in class anyway. Not in this class, but that was other classes. But that shows you a way you can do that. Okay, vocabulary, you should know what Boolean represents. Relational operator, logical operator, short circuit, probably not as important. De Morgan's law is not as important. Conditional statement, you should know what that is. Branch, it's kind of important. Chaining, not so important. Nesting, not so important. Flag, you should know what that is. Recursion, even if you can't do recursion, you should know what the concept is. Base case, binary. Okay. Okay, this would probably be a good one to assign. I haven't assigned anything out of this chapter yet. Exercise 5.4. It is a math related one, except for you don't have knowing math on it. This checks, you pass in, what do you pass in 4 integers for? Opens to the end. So you pass in A, B, C, and N, and all you're checking to see if N is greater than 2 and this is true. Well, we just looked at that. I may not have my code there anymore. Remember how we put an and here? So you're going to need to use that in the method you call. So N has to be greater than 2. So your first condition will be N is greater than 2. And then over here, you want to put this in there. A to the n power plus b to the n power, and you're checking to see if that's equal to c to the n power. Now, hint on that, when you build that into the if statement, you should have 2 equals, not 1 equals. And they also give you a hint to use math.pow. That returns math to a power. So, for example, printf. %d to, or caret, %d equals %d slash n. So 4 to the third power is going to equal to math dot pow, lowercase or uppercase, P, there it is, P-O-W. Then we do our numerator, which is 4, and our denominator. Not sure where that came from. That's our base and our exponent. Okay, double for format specifier. So F. 4 to the third should give us 64, I think. 4 to the third is equal to 64. But that's what they're referring to. Since you have to take a to the n power, you could have variables a and n, and you would call them in that manner. So that's a to the n power. This looks like a recursion one because it's going from 99 down, and so I'm guessing they want you to call itself. So we're not going to do that. Include a recursive method. We already talked about returning values, but that's probably not a bad place to stop. So I want to really get into chapter 6 and give you time to work on exercise 5.4. Is there any questions on any of that? Okay. Did the recursion make any sense? Oh, okay. See, and I'm probably not even wrapping my mind around where its true power is. Yeah, yeah, and that's a part because a lot of times recursion you don't know how many times you're going to call it, so you open yourself up to Stack Overflows just from that issue right there. Now, if you think about how many folders are on your potentially on your hard drive and how deep it could go, that probably to overflow a stack. I think I've done it in the past many times, but I did it because of poor programming. Like that one where it said you're going to call this infinitely. If I had ran that, we would have seen a Stack Overflow. We'll go ahead and stop there, and then on next class we'll get into chapter 6.